Okay, guys, so this is number 4 on the chapter 15 review. Um, we are given a problem where we are given the KP and the temperature, and if the partial pressures of NOBR and NO are equal at equilibrium, what is the partial pressure of BR2? Okay, so it's probably worth mentioning that we should definitely write almost always. It's almost always beneficial to write the expression for Kp or Kc whenever it's given. Whenever it's an equilibrium problem, it's always helpful to have that. So let's do that. So then our Kp is equal to the partial pressure of NO to the second power, the partial pressure of Br2 all over the partial pressure of NOBR squared. Okay, so notice this is like essentially the same equation as the Kc. However, the only difference is that we are including partial pressures as opposed to concentrations. Okay, so let's just get that out of the way. It's essentially the same equation. All we're doing is we're saying, hey, everything that goes in this, instead they're partial pressures. Okay, so we're given that the value of Kp has a value of 0.416. And if the partial pressures of NO and Br are equal, what is the partial pressure of Br2? Oh, well, if we look at that, well, okay, notice that NO and Br are both raised to the second power in this problem, right? And therefore, that means that if they had numbers that were equal, let's put an example, like let's say they were like 3 and 3, well, it would be 3 squared and 3 squared, 9 and 9, and they would both cancel. Okay, so that means then that really our Kp expression can be reduced and simplified such that our Kp is equal to the partial pressure of Br2. And voila, we have reached it. So then that would imply that the answer to this problem would be that what would the partial pressure of Br2 be? Well, it would be equivalent to the partial pressure equilibrium constant. So it would be that the partial pressure of Br2 is equal to 0.416 atm. Okay, and that's pretty much it. We've solved the case. So let's just do a quick recap, right? So anytime you're given a Kp or a Kc, make sure you write out the equation for it, right? If you're looking at this equation, or rather this question, and you're not really sure what to do, it makes sense to start writing out expressions that we have that we know, right? Because then you can look at it and be like, oh, NO and NOBR are equal. That would mean that given this equation that they would cancel in the Kp equation. Okay. And then that would lead you to the right answer. So this is the problem solving that you need. Fenton's never gone over a problem like this, but that doesn't mean that you can't use your critical thinking to solve for this, right? So what's the big tip here? The big tip would be always write out Kp and Kc. Okay? That's a horrible Kc. Okay? Make sure you always do that. The equations for it, because that will always kind of, center where your thinking is going to be, and it'll ground it, and that will allow you to solve for this, okay? Cool. Hopefully that helped. Pretty quick video. The next couple of videos will be a little more intense, so we'll go from there. Okay? Thanks.